Hey guys, so this video is basically just the review answer sheet for 5, 1 through 2. So feel free to look at your worksheet while you do this or just kind of take notes so that you can correct your answers, hopefully by 3 p.m. today if you happen to get there on time. So I'm going to go ahead and start. We're going to go ahead and start the lesson. I don't know why this is not moving, but it's not. Oh well. All right, we're going to go ahead and get going. All right, so basically, first 3 questions are pretty straightforward. Tangent x cotangent x is a reciprocal identity, and so tangent x times cotangent x is just going to be 1, and 1 over cosine x is secant x. The next one, 2 cosine squared x minus sine squared x is equal to 1 minus sine squared x. Well, I can see that the left side is not the same as the right side, and that the right side only has signs in them. So I'm going to try to get the left side to only have signs in them using Pythagorean identities. Cosine squared x is the same thing as 1 minus sine squared x. And we can verify that identity pretty quickly. Number 3 is pretty straightforward too. Number 3, basically I have tangent of x, 1 over tangent x plus 1 over cotangent x. 1 over tangent of x is cotangent x. That's a reciprocal identity. And 1 over cotangent of x is tangent of x. So let's go ahead and try something a little bit different. Cosine x cotangent x all over 1 minus sine x minus 1 is equal to cosecant. Now, depending on how you do this problem, it could take a really long time. It could take a moderate amount of time, or it could be really quick. I'm going to kind of pick the one that's in the middle. So cosine x times cotangent x is the same thing as me saying cosine x times cosine x all over sine of x. That's kind of the same thing there. And then we're going to say all over 1 minus sine x minus 1. And the question is, does it equal cosecant of x? Okay, so I have cosine x times cosine x all over sine x. I'm going to rewrite this as cosine squared x all over sine x all over 1 minus sine x minus 1. And the question is, does it equal cosecant x? Okay, cosine squared x. Okay, so I'm thinking about this in terms of what I want on the other side. The other side is cosecant of x. Cosecant of x is a sine function. It's the reciprocal of sine. It's 1 over sine. So it'd probably behoove me, it'd probably benefit me to go ahead and change anything on the left side to be in terms of sine. Well, cosine squared x, using a Pythagorean identity, cosine squared x is equal to 1 minus sine squared x. So I'm going to go ahead and rewrite that. So I have 1 minus sine squared x all over sine x. I know there's a triple fraction, all over 1 minus sine x minus 1. So at this point, I don't really like that there's a triple fraction going on, so I'm going to go ahead and keep it, switch it, flip it. So I'm going to keep the first fraction, 1 minus sine squared x all over sine x times, keep it, switch it, flip it. So we're going to flip it, 1 over 1 minus sine x minus 1. Question is, does it equal cosecant? Okay, all right, so let's keep on going with this. 1 minus sine squared x, if I factor that, that's a difference of squares. It factors to 1 minus sine x times 1 plus sine x all over sine x. So let me undo that. All over sine x times 1 minus sine x, 1 over 1 minus sine x minus 1. So using a different color real quick, we can probably see here that 1 minus sine x and 1 minus sine x are going to cancel out. Okay, so that leaves me with this. 1 plus sine x all over sine x minus 1. Question is, does it equal cosecant x? Well, really, we're kind of on the final stretch here. I'm going to go ahead and split this fraction up into 2 pieces. This is the same thing as me saying 1 over sine x plus sine x over sine x minus 1. The question is, does it equal cosecant x? Well, 1 over sine x is cosecant x. Sine x over sine x is 1 minus 1. Does that equal cosecant x? Well, yeah, those two cancel, and this right here is verified. So I know that that took a lot of steps. Obviously, you could have taken a different path, but that is the path that I took. All right, let's move on to the next page. Let me see if I can move my... I guess I can't move this icon. Sorry, give me one sec. It really does not want me to. Okay, I guess not. All right, we're going to keep on going. I'll just try to move my face out of the way as much as I can. All right, tangent squared x over secant x, does it equal sine x tangent x? Okay, well, the first thing I might do is write everything in terms of sines and cosines. So I'm going to go ahead and pick the left side. You don't have to pick the left side, but I'm going to pick it. All right, that's the same thing as me saying sine squared x over cosine squared x all over 1 over cosine x. Does that equal sine x tangent x? Okay, well, if I rewrite this just a little bit, I could rewrite this in terms of like a keep it, switch it, flip it. So I could say that this is sine squared x over cosine squared x times cosine of x times cosine of x. So what we can see here is that a cosine is going to cancel and one of its cosines will cancel. So cosine squared divided by cosine is just cosine. So one of the cosines in the denominator cancels and the cosine in the numerator cancels. All right, so now what I'm left with is this. I have sine squared x all over cosine x. Does it equal sine x tangent x? And if you don't see it, believe it or not, we're actually really close to the answer here. All right, so what we're going to do, sine squared x is the same thing as sine of x times sine of x. And technically, this is all over cosine of x. Okay, I'm going to get my highlighter out for a minute. If I highlight sine x over cosine x, sine x over cosine x is tangent x. That is tangent. And so this is going to be tangent of x times whatever's left, which is sine x. And so that right there also verifies. Okay, let's try the next one. Cotangent x minus tangent x is equal to secant x times cosecant x minus 2 sine x. So I know a lot of us had issues on this one. It took us a really long time. The reason it took you a really long time is I didn't teach you one of the identities because you technically don't need it. You could technically use power reducing or double angle, I think, on this one, but we're not going to use that. We're just going to kind of figure it out on our own. So traditionally speaking, you're going to start on the most complicated side and kind of move your way back. I'm actually going to start on the least complicated side just because I see something special here. If I write cotangent of x and tangent of x in terms of sines and cosines, I get cosine of x all over, oops, it's the other way around. I get sine x all over cosine x minus, oh, I did it again. Oh my goodness, I did it again. Okay, sorry. I get cosine x over sine x minus sine x over cosine x. Okay, so that's kind of what I see here first, cotangent and tangent. What I could do here is try to get a common denominator so I could actually subtract these. So I'm going to multiply the first by the denominator of the second. So let me go ahead and change my color for that for a minute. We're going to multiply the first by the denominator of the second. So we're going to say cosine x, and we'll multiply the second by the denominator of the first. So sine x, sine x. Okay, so if I go ahead and simplify this out, what I'm going to get is cosine squared x minus sine squared x all over cosine x, sine x. And the question is, does it equal secant x times cosecant x minus 2 sine? Okay, so what I see here is I see that there's a cosine in the denominator. Well, I have right here on this right side a secant pulled out of everything. Secant is 1 over cosine. So what I'm going to do is I'm going to pull this 1 over cosine out front. So I'm going to get 1 over cosine x times cosine squared x minus sine squared x all over sine of x. And I want that to equal secant. I want that to equal secant times cosecant minus 2 sine. Okay? Well, 1 over cosine, we've already established that's secant. So actually we're getting closer to making this look like the other side. All right, so if I look on the inside of this function here on the right-hand side, I have cosecant of x minus 2 sine x. These are all in terms of sines. Cosecant is 1 over sine, and sine is obviously already in terms of sine. So a good hint of what I could do here is I should get everything in the parentheses to be in terms of sines. So I'm going to use a Pythagorean identity to rewrite cosine squared x in terms of sines. So cosine squared x is the same thing as 1 minus sine squared x. Then we'll say minus sine squared x, just go and copy and paste, all over sine of x. Question is, does it equal? Does it equal secant times cosecant minus 2 sine? Okay, well, we're getting really close. We have everything on the inside in terms of sines. All right, 1 minus sine squared x minus sine squared x is 1 minus 2. Ooh, that's awesome. 2 sine squared x all over sine of x. So hopefully you can see that we're getting really close. I want this to equal secant times cosecant x minus 2 sine. Well, I see a 2 sine, it's just squared, and I might actually see a cosecant here. I'm going to go ahead and distribute that sine into all of the pieces. So really what this is going to be is it's secant x times 1 over sine x. Ooh, that sounds like cosecant. Minus 2 times sine squared x all over sine x. And I want that to equal secant times cosecant minus 2 sine. Well, hopefully we can kind of see it at this point. The sine in the denominator is going to cancel with one of the squares. And so what I'm left with is secant times 1 over sine is cosecant. So we're going to say cosecant x minus 2 sine of x. And that right there is verified. So I know that took a lot of steps. Maybe you have to be a little bit creative in this one. I would say that was the hardest one on the review sheet. But let's keep going. Surprisingly, number 7 is not the hardest one on the review sheet. I know it looks kind of complicated, but it's actually not the most complicated. What I'm going to do first for number 7 is I'm going to go ahead and take some more common factors out of the expressions I see. So I see secant to the 6x times secant x times tangent x. That is the same thing as me saying secant to the 7th x times tangent x minus secant to the 5th x times tangent of x. And I want that to equal secant to the 5th x tangent x, tangent to the 3rd x. All right, so what I'm going to do is I'm going to go back to, I guess, the first time I learned about greatest common factor, and I'm going to find the greatest common factor in both of these terms. All right, well, the greatest common factor that I'm seeing is secant to the 5th times tangent. So that's what I'm seeing. So we're going to pull that out. So secant to the 5th times tangent, I'm going to pull that out. And what's left on the inside is going to be secant 5, 6, 7, secant squared x minus, okay, this one, the only thing that's left here is 1. And I want this to be secant to the 5th x tangent squared cubed x. Okay. All right, secant squared x minus 1. I hope that rings a bell for us. That's a Pythagorean identity, and you can look it up and do some manipulation. But secant squared x minus 1 is tangent squared x. So let's go ahead and rewrite that. This is secant to the 5th times tangent x times tangent squared x. Well, if I simplify that, that's going to be secant to the 5th times tangent to the 3rd, which is verified. That makes the left side equal to the right side. Okay? All right, let's keep on moving. All right, this one here, cosine x minus cosine y all over sine x plus sine y. This whole thing, it looks really complex. All I'm going to do is use my same strategies. I want to get common denominator. So I'm going to multiply the first by the denominator of the second. So cosine x plus cosine y all over cosine x plus cosine y. And then this one, I'm going to do the same thing. So I'm going to say sine x plus sine y, and then sine x plus sine y. Okay, so if you can see right here, this first expression, I'm going to go ahead and highlight it. This is a difference of squares. Cosine x plus cosine y times cosine x minus cosine y. Those two are conjugates, which means if I multiply them together, they get the product of a difference of squares, which means the middle two terms, like if I said a plus b times a minus b, it would be a squared minus ab plus ab minus b squared. So the middle two terms always cancel in that scenario. So I'm going to go ahead, just for time's sake, and go ahead and do that. So what I'm going to get in the top is going to be cosine squared x minus cosine squared y plus sine squared x minus sine squared y. And that's all over a common denominator of cosine x plus cosine y times sine x plus sine y. Okay. All right, so what we're going to do next is we're just going to see what I can simplify. I'm actually going to put all of the x terms on one side and all of the y terms on the other, just of the fraction. So not like over the equal sign. I want to know if this equals 0. So I'm just going to move things over using commutative property. So I get cosine squared x. Let's move the other x term next to it. So plus sine squared x. Ooh, I hope that rings a bell. Minus cosine squared y minus sine squared y, all over the same denominator of cosine x plus cosine y times sine x plus sine y. Okay, well, let's get my highlighter out because I'm actually seeing some important things here. Isn't cosine squared x plus sine x, isn't that equal to 1? That's a Pythagorean identity. Yeah, it is. Okay, so also, if I go ahead and highlight this, I have minus cosine squared y minus sine squared y. Sorry, there should be a squared there. Well, if I pull a negative 1 out, this is going to be the same thing. In fact, let me just kind of erase for a minute. This is going to be the same thing as negative on the outside, and it's going to be cosine, don't write in purple, cosine squared y plus sine squared y, which we should also see that also equals 1. So when I highlight that one also equals 1. So let's go ahead and simplify. This will be actually our final step here. We're really close to the answer. This is going to be 1 minus 1 all over cosine x, cosine y, plus times sine x plus sine y. Well, 1 minus 1 is equal to 0, and 0 over any number besides 0 is equal to 0. And so this right here verifies to be 0. All right, let's move on to the last question before true or false. All right, secant to the fourth x tangent squared x, is that equal to tangent squared x plus tangent to the fourth x all times secant squared x? What we could do here is we could literally just distribute in on the right side. So I want to know, does secant to the fourth x tangent squared x? Does it equal this? Let's go ahead and distribute in. I get tangent squared x times secant squared x plus tangent to the fourth x times secant squared x. Okay, I'm going to go ahead and rewrite these in terms of sines and cosines, see if anything cancels. So what I'm going to get here is tangent, which I'm going to write as sine over cosine, my bad. All right, so this is going to be sine squared x over cosine squared x times 1 over cosine squared x plus, this is sine to the fourth x. You know what? Actually, I don't like this idea anymore. I'm taking it back. I think maybe my best bet is actually to pull out a common factor. Sometimes you see this. I know that at the beginning of the lesson, the problems were already done for us. I actually made the same kind of error at the beginning of the lesson where I kind of went one path and then realized the path was not going to take me anywhere that was convenient, and so I switched. That's kind of the name of the game with verifying. Sometimes you're going to take a path that is super easy, you got it, and then sometimes you need to realize, hey, I don't think that's going to get me where I want to go. The thing that really clued me off to that is I see addition here, and there's no addition here. There's only multiplication. So a really great way to go from addition to multiplication or multiplication to addition is the Pythagorean identity. So I'm actually going to see if I can pull out a factor and see if there is a Pythagorean identity in there. Okay, greatest common factor that I'm seeing tangent squared. Tangent squared, secant squared. So tangent squared, secant squared. And then what's left is 1 plus tangent, that's better. 1 plus tangent squared x. 1 plus tangent squared x. All right, so hopefully we can see that this right here is a Pythagorean identity. 1 plus tangent squared x is secant squared x. So this is going to be tangent squared x times secant squared x times secant squared x. And so we can actually see that this totally verifies. This is tangent squared x times secant to the fourth x, which is the same thing as the left. So kind of a key takeaway here, and I should have, I guess, given you guys more emphasis on this the whole time. This is actually what I'm looking at, is that when I see addition on one side and I see just multiplication on the other, pretty much the only way to transfer from one to the other is the Pythagorean identities. Okay, I don't want to keep this video much longer, so I'm actually going to stop here. You guys do have a quiz tomorrow, so make sure you're studying for that. Use this sheet as your study guide. and I will see you on Tuesday.